1 over x plus 1, put it away please, equals 12 over x squared minus 1 plus 3. Can I use cross multiplication, Elliot, to solve this equation? No. No, there's two terms on the right. So let's find a least common denominator. Before we find a least common denominator, we have to factor everything in the denominators to make sure that we've got, like this one, x plus 1, that's a factor. But what about x squared minus 1? How do I factor that? Ezrin, how do I factor something like this? Do you remember? No? It's the difference of squares. X times x, 1 times 1. So this will be x minus 1 times x plus 1. Does that make sense? And then the 3 doesn't really have a denominator, just 1. So our least common denominator that I want to use is going to have the x plus 1, which both of these two do, but it also needs to have the x minus 1. So my least common denominator is x plus 1 times x minus 1. So I'm going to go through and rewrite my problem, and you guys don't have to rewrite. If you can keep your work organized. I'm going to multiply by this least common denominator. What's going to happen first is I'm going to have the 4x plus 1 gets multiplied by x plus 1 times x minus 1. But the x plus 1 on the bottom is going to cancel out with this one. So I'm writing out all my work because I'm the teacher and I need my work to make sense to you. If you can do this quicker, like, oh, I'm noticing that this LCD and this term have the x plus 1 in common, it's going to cancel out anyway, then you can just jump to 4x plus 1 times x minus 1, because that's what we're going to end up with here. 4x plus 1 times x minus 1. And then equals 12 times x plus 1 times x minus 1 over the denominator that was already there. Those are going to cancel out. And then the 3 times x plus 1 times x minus 1. And that didn't have a denominator to cancel anything out, so that one will still have all of those factors. All right, from there, solve the equation. These ones do start to get pretty messy. Distribute together. Because I have two binomials that have to distribute here, it's going to be a little bit messier. I get 4x squared minus 4x plus 1x minus 1. So this is 4x squared minus 3x minus 1. And then on the right side, I have the 12. And then x plus 1 times x minus 1, if you remember from the way we factored it, is x squared minus 1. And then I can multiply the 3 into that. So plus 3x squared minus 3. Look up here right now and see where you're at. This is where I told you get this solved, set equal to 0. So what I did first was I brought the x squared term over, so I subtracted 3x squared, which gave me just a single x squared. That's nice because that means it's going to factor easily. And then I brought the 12 and the negative 3. You could have put them together first to get 9 and then subtracted it over, but I just subtracted 12, added 3. So it was negative 1 minus 12 was negative 13 plus 3 was negative 10. And then I had this negative 3x that didn't have any common terms. And then I factored this, x plus 5, x minus 5 times x plus 2. And that means x equals 5 and x equals negative 2. Neither of those answers are restricted values because they're not numbers that would make the denominator 0. We have not seen one that does that yet, but they might come up. I'm just going to show you in your book, example 4. I'm not going to do this whole thing, but they ended up with 2 solutions when they solved this one. In fact, with the 2x squared, that's harder to factor. Most of you would use the quadratic formula at that point, or you can try to factor it if you want. But from there, they got these 2 solutions. But if you look back at their original problem, x minus 3 was one of their denominators. Oh, and x plus 3. This is the one that ends up being a problem. If x equals negative 3, and you plug it into this denominator, it's going to make a 0 in the bottom. So what happens is that one's actually an extraneous solution. We don't count it as one of the final solutions. So in this problem, their only answer should be the x equals 3 halves. And they say that later. They do all the checking, and then they list that as the x equals 3 is extraneous, and the 3 halves is a true solution. Okay, so I don't want to do another example like that. I just thought that we could look at the one in the book. Okay, any questions on that? It's messy, and you're going to have to practice it. Okay, Brittany. Minus 14. So possibly, if you look back at your work, did you have this as a negative 3? Or a positive 3? Yeah, if it was a positive 3, then you would subtract it over here, and that would have made that further negative, probably. So we multiplied these together and got x squared minus 1, and then multiplied the 3 in. So we had a minus 3 here that we had to bring over. Don't know if that's where you messed up or not. I can look at it later, too, if you want. Okay. We have one more concept today, and that's just kind of uses some of these skills, and that is, how do you find an inverse? So if you want to make kind of a note to yourself, we're sort of changing gears just a little bit. How do I find an inverse of a function when we're talking about rational functions? So let's say I'm giving you f of x equals the rational function 2 over x plus 3. And I want you to find the inverse of that function. I'm hoping this is going to be somewhat review. It's just the process is a little different because it's a rational function and not one of the functions we've been dealing with before. What is the concept of inverse functions? What do we do when we find an inverse? In any kind of problem, if you want to find the inverse. Tori? No, but that's actually, I didn't think about that. That's good if you're talking about like numbers. Inverse is sort of like the reciprocal. Okay. What's an inverse function? The inverse, how do I find an inverse of a function? There you go. You switch the y, and the x. You switch the domain and range. And so we're going to switch our, well, first of all, let's rewrite this as y equals. It makes it a little bit plainer. And then switch the x and the y. So really the equation is x equals 2 divided by y plus 3. That's technically the inverse. But we're going to solve it for y. So what we need to do here is find the inverse because no one remembered it except Shannon. Everyone except Shannon needs to write down switch the x and y. That's what you do when you find an inverse. And then you solve for y. So how am I going to solve this for y? Well, could we use cross multiplication on this problem? Some people are saying no, but technically, do we have one thing on the left and one thing on the right? This one just doesn't look like a fraction, but can I make it look like a fraction? Yeah. And now I can use cross multiplication. We like that because that's the easier method. And so I'm going to multiply, get 2 times the 1 is 2, and then x times y plus 3. Just the trick here is don't actually distribute that x in because we are trying to solve for y. I actually want to get rid of the x, and I want to get rid of the 3 from this side. And so the next step, because it's x multiplied by this stuff, is to divide by x. So we get y plus 3 equals 2 divided by x, and then subtract the 3. So y equals 2 divided by x minus 3. Or you can write it as the y first, 2 divided by x minus 3. There's our inverse function. It is a function. It's just another rational function 2 divided by x minus a number. I think your book would probably name it like g of x, but I don't really care what you do as long as you've got it in the right format. Okay, so your assignment today, lesson 7.5, page 3, put it over here, 396, numbers 2, 5 through 9 odd, 16, 18, 19 through 22 all, 25, 27, 28, 38, 40, and 42. That's your required assignment. All of those are going to be similar to the ones I showed you for the most part in class. There's two other ones, 29 and 30, that would require the quadratic formula or just, I think quadratic formula or maybe special factoring techniques to solve. So these would be considered extra ones if you want to do those, but they are not required.